Now let's just move on further towards the question number 5, which says a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which BC is divided by the point of contact of the lengths 8 cm, 6 cm respectively. Find the sides AB and AC. So we just have to find out the sides AB and AC. So let us suppose this is nothing but the figure that I have. So it says that CD is actually nothing but 6 cm, and we have further the side which is nothing but BD as nothing but the 8 cm, and we know about the radius of the circle which is nothing but OD. Now let us suppose if I'll do a little bit of construction over here, and I'm just joining this O and F together, this O and E and O and F all together. So let us suppose if I'm joining them in such a manner, then definitely we know about this concept that this is nothing but a perpendicular, this is nothing but a perpendicular, and this is again nothing but a perpendicular over here. Since this is nothing but a tangent, so it must be at a 90-degree angle with the radius of the circle. Again, this is also 90-degree angle, and again this OD also makes an angle of 90° with this BC. Now let us suppose if we just have to find out the sides AB and AC. So first of all, we know that this C point, you can see over here, this C point is actually an external point, and if this is an external point and it is drawing two tangents to this particular circle, then if this is 6 cm, then this is definitely is also of 6 cm. We know about this concept, the length of the tangents drawn from an external point to the circle is always equal. So if this is 6, this is also 6. If this is 8, then this is also 8 cm. And let us suppose if I'm just taking this side as x centimeter, so this is also would be of x centimeter. Now let us suppose if I'm just starting with the solution for this question as nothing but let AF is equal to AE is equal to the x centimeter, since we know about the concept that the length of the tangents are always equal. So using that particular concept, now I am just moving on further with the, it implies that AC is nothing but x plus 6. You can see all by yourself that AC is actually coming out to be a sum of these two segments. It means x centimeter plus 6 centimeter, which is x plus 6 centimeter. Furthermore, BC would be nothing but 6 plus 8, which is nothing but is equal to 14 centimeter. And furthermore, it implies AB is nothing but x plus 8 centimeter. This is x plus 8 centimeters. Now we have the three sides of the triangle as AC, BC, AB, which is x plus 6, 14 and x plus 8 centimeter. So first of all, we just wanted to find out the value of the x, because if we have the value of x, then we are done with it. So let us suppose if I am just taking or using the concept of the area of the triangle, since we know that the area of the triangle is half into base into height, and moreover we can use the concept of the Heron's formula if we just wanted to find out the area for this particular triangle. So from these two formulas, we will now find the value of this particular x variable. So let us suppose if I'm just starting with the finding out the semi-perimeter of this particular triangle. So we know that S is nothing by Heron's formula. We know that S is nothing but is equal to AB plus BC plus CA divided by 2. So let's just substitute all the values over here in order to get the value of the semi-perimeter. So this would be nothing but AB is nothing but x plus 8, BC is nothing but 14, this is plus further again, this is nothing but x plus 6 divided by 2. So as you can see over here, S is nothing but coming out to be x plus x, which is nothing but 2x plus of, we have 14 plus 14, this is nothing but 28 further divided by 2. If I'll just take a 2 common out of it, this would be x plus 14 divided by 2. 2 and 2 get cancelled, so semi-perimeter is coming out to be x plus 14. Now let's just talk about after the semi-perimeter, let's just talk about the Heron's formula. So let us suppose if I'm just dividing further. So let us suppose if I'm just talking about the Hurren's formula. So according to the Hurren's formula, we know that the area of the triangle is nothing but is equal to the square root of S minus A, S minus B, S minus C. This is nothing but the area of the triangle. So let us suppose if I'm just taking this particular side as nothing but A. Let us suppose this is my A, this is nothing but my B, because B is actually nothing but the side which is opposite to the vertex B. And let us suppose if I'm taking this side as nothing but C. Let's suppose if I'm just taking this C, and we can move on further. This is our C. So it implies that I'm just taking the BC side as nothing but my A. I'm just taking AC as nothing but my B, and this is my C. Now let's just plug in all the values over here. This is nothing but square root of S. What is S? S is nothing but X plus 14. S minus A, X plus 14 minus of X minus of I have taken B first, minus of 6. So this is X plus 14 minus of, we have 14, and further we have X plus 14 minus of X minus of 8. Now let's just calculate this whole. This would be nothing but square root of X plus 14, and X get cancelled with each other. This is nothing but 8. Further we have X, because 14 get cancelled with each other. X get cancelled with each other. This is nothing but 6. So at the end, what we are getting? We are getting square root of X plus 14, 48X. And if I'll just sort it out, we are actually getting the answer as nothing but 48X square. As you can see, this is 48X square plus of, this is nothing but 672X. If you multiply 14 and 48, you will get the answer as 672X. So this is actually nothing but the area of the whole triangle ABC. This is actually nothing but the area of the whole triangle ABC. Now let us suppose if I'm calling it as nothing but the equation number 1. Now furthermore, we can also find the area of the triangle using the concept of half into base into height. Now let us suppose if I'm just talking about the area of the triangle ABC would also be is equal to the area of the triangle AOC plus area of the triangle BOC plus area of the triangle AOB. So I am just talking about the area of this whole triangles by taking the 3 smaller triangles over here. That is, this is the triangle 1, this is the triangle 2, and this is the triangle 3. Obviously the sum of these 3 triangles would also be equal to the sum of the whole triangle. So I'm just talking about this only. So since we can start with the area of the triangle AOC, let's just see AOC. In AOC, we can write it as half into base. Let's just see AOC. This is AOC. The base over here is nothing but AC, and the height over here is nothing but OE. So this is nothing but half into base. Base is AC, height is OE. In the similar manner, we can talk about BOC. So this would be nothing but half into base. Base is BC, and height is nothing but OD. Plus, in the similar manner, we can say this is half into base. Base is nothing but AB, and height is nothing but OF. This is OF. And now since we know that all these are nothing but the radii of the circle, and we definitely know about the radii is nothing but 4 centimeter. So this is also of 4 centimeter, and this is also of 4 centimeter. So let's just plug in all the values over here in order to get the area of the triangle again in the formation of half into base into height. So let us suppose this is my half AC. What is the AC value? AC value is actually nothing but X plus 6. This is X plus 6, and OE is nothing but 4. So plus we have half into BC. BC is nothing but 14, and OD is nothing but again 4. Further we have plus of half into AB. What is AB? This is X plus 8 into OF. OF is nothing but 4. Now we can sort it out as nothing but 2 into 2 is 4, 2 into 2 is 4, and 2 into 2 is 4. So it means that we can take 2 common out of every particular term. So this would be nothing but x plus 6 plus of the value which is left over here is nothing but 14, plus over here the value which is left over is nothing but x plus 8. This is x plus 8 because we have taken 2 common out of it. Now further this can be written as nothing but 2 into x plus x is nothing but 2x plus 28, 2x plus 28. So at the end we are getting the area, we are getting the area of the triangle ABC. We are getting the area of the triangle ABC as nothing but is equal to 4x plus of 56. 4x plus of 56. We are getting this as nothing but the area of the triangle. Let us suppose if I am calling this as second. Since we know that we are just talking about the area of the triangle ABC, and either if we'll find the area from the Heron's formula or either if we'll find the area from half into base into height, they would be equal to each other, which implies that the very first means the first side is actually is equal to, or the first equation would be is equal to the equation number 2. It is quite obvious that the area of the triangle would be similar to each other. So it implies that 1 is equal to 2, equation 1 is equal to 2. So let's just take equation 1 and 2 equal to each other. So this is 48x square plus 672x, which is nothing but is equal to 4x plus 56. Now let's just take the squaring on both sides. So squaring on both sides implies that this is 48x square plus 672x, which is equal to 4x plus 56 whole square. Now let's just solve this 4x plus 56 whole square. Again, this would be a plus b whole square. Let's just apply the algebraic identity over here. This is 672x, which is equal to, this would be nothing but 16x square plus of, further we have this 56, we have this 56 whole square. So 56 whole square is actually nothing but 3136 plus of this would be 2 into a into b, and 2 into 8, 4 is nothing but 8, and 8 into 56 we are taking is nothing but 448 of x. So at the end we are getting this particular equation altogether. So let's just sort it out. If I'll take all the elements over here, then we will get the equation as 48 minus of 16, this would be nothing but 32x square plus of we have 672 minus 448, this would be nothing but 224x minus of 3136, which is equal to 0. So at the end we are getting this equation. Now we can take 32 common out of it. This would be nothing but x square plus of this is nothing but 7x minus of 98, which is equal to 0. Let's just take 32 towards the other side. This would be nothing but x square plus of 7x minus of 98 is equal to 0. Now let's just factorize this quadratic equation. We know how can we factorize. Just look out for the two numbers whose multiplication is 98 and whose subtraction is nothing but 7. So this is nothing but 14 and 7 minus 98 is equal to 0. Let's just take x and x plus 14 minus 7. This would be x plus 14 again, which is equal to 0. So at the end we are getting x plus 14 into x minus of 7 is equal to 0. So either we are getting x as minus 14 or either we are getting x as equal to 7. So this value would be neglected because the side of the triangle cannot be negative. The side of the triangle cannot be negative. So x is equal to minus of 14 is a neglected case. So hence x is equal to 7 is the one that we require. So it implies that we are actually getting x is equal to 7 at the end. So hence it means that this is nothing but 7, this is nothing but 7, this is nothing but 7. So what we have to find? We have to find the side AB and AC. Now you can see all by yourself that actually at the end we are getting AC as nothing but, this is 7 and this is nothing but 6. So this is nothing but 13. This is 13 centimeter, and again we have this as nothing but 7 and we have this as nothing but 8. So 7 and 8 is 15. So this is nothing but 15 centimeter. So at the end the answer is nothing but 13 centimeter and 15 centimeter, which we are getting. And This is all just because of or with the help of the Heron's formula and the area of the triangle, that at the end we are getting the answer as nothing but AC is 7 plus 6, which is nothing but 13 centimeter, and AB is nothing but 7 plus of 8, which is nothing but is equal to 15 centimeter. And with this question, this is nothing but the end of the chapter, which is nothing but the circles. I hope all the concepts, the theorems that are related with the circles are all clear to you. Now let's practice more and more questions all by yourself.